Let's look at warm-up number 11. Number 1. A grown man will burn roughly 100 calories for each mile run. How many calories will be burned when a grown man runs 6.5 miles? So, the first two questions are what is the independent quantity and what is the dependent quantity. So, independent means the thing that you can change. So, if you want to burn more calories, you do what? Run more miles. So the thing that you can change is the miles run. The independent is the miles run. We can change that. So you want to burn more calories, you run more miles. You want to burn less calories, you run less miles. So what's the dependent quantity? What did we just say depended on that? The calories burned. Calories burned is the dependent quantity. It depends on how many miles you run. Does that make sense? Sometimes I have a hard time in my own mind figuring out which one's independent and which one's dependent. So you have to think about what you can change. You can change the calories burned, but how do you change the calories burned? You have to move more. So that's the one that's independent. So we practiced that a little bit more in our third unit. Write an equation to describe the problem. So, 120 calories for each mile. Do we know how many miles he runs? Oh, how many calories will he burn when he runs 6.5 miles? So, write an equation to describe the problem. So, it's 120 calories times what? 6.5 miles equals, and we don't really know the answer. We don't usually put a variable there, but that's really the unknown, right? How many calories are burned? I'm not going to put that there because then that makes it look like that's the way we set up a problem. All right, so what are we going to do? 120 calories times 6.5 miles. Draw my turtle head. 5 times 0 is 0. 5 times 2 is 10. Put your 0 and carry your 1. 5 times 1 is 5, plus 1 is 6. Check off carried numbers. Draw a turtle collar, and what's the last step? Lay a turtle egg. Y'all know you wanted to say that. All right, move to your 6. 6 times 0 is 0. 6 times 2 is 12. Put your 2 and carry your 1. 6 times 1 is 6, plus 1 is 7. Now we add. Let's add. 0 plus 0 is 0. 0 plus 0. 6 plus 2. 7. 7. So is it 7,000? What did we forget, Spencer? The decimal. How many digits are past a decimal? Just one. This one right here. 1. There's no decimal over here, so we just need one digit past the decimal. And so what is the answer to our question? A grown man will burn calories when he runs. Yes. All right, find the area of the shape below. Break the larger shape into smaller pieces if needed. So this is called the area of a composite figure. You should have learned how to find the area of a composite figure last year in 6th grade. It's super fun. I see 3 different ways to solve this one. Okay, you can break it apart into pieces. That's decomposing. Or you can add this corner back on. Find the area of the whole thing, find the area of this corner, and then do what? Subtract that off. So most people like decomposing it or breaking it apart. I actually prefer the other way. It's less math because then you're only finding the area of this and the area of the whole thing and subtracting. But on this unit, we will do this again this year in unit, I think it's 4. But you will get to use a calculator on it, so it won't be super difficult. To me, the easiest way to break this one apart is to draw this line here. And what shape did we make down here? A rectangle. And then we've got to break this apart right here. And then we break it into another rectangle and then a triangle. And then we find the area of each shape, and then what do? We add it back together, right? So the first thing we have to do is we have to know our formula for area of these shapes. And this is actually in your journal on our formula page, but to save time, we're going to say the area of a triangle equals, so that's a triangle, area of a triangle is, does anybody remember the formula? 1/2 of the base times height. So 1/2 of base times height. Because this is half of a square or half of a rectangle. Because if we put this whole thing here, that would make this whole shape a rectangle. But because it's only half of it, we have to do half of the base times the height. Okay? All right. And so what is the area of a triangle? Or of a rectangle? Length times width, or also base times height. All right. So let's start with this bottom rectangle. What are we going to multiply together? What's the base? 11 and 4/10. 11 and 4/10 times the height of 4. And I'm just going to do that on the calculator to save time. So 11.4 times 4. And we get 45 and 6/10 meters squared. Remember, because we're doing math with 2 dimensions, it's meters squared. All right, let's talk about this shape. What is our base? It is 8.4. And what is our height? Is it 8 or is it 4? It's 4, because this whole thing is 8. And we know that this bottom half right here is the same as this. This is 4 and that's 4. So if this part's 4 and the whole thing is 8, that makes this top part 4 meters. And so we're going to do 8.4 times 4. And we get 33 and 6/10 meters squared. All right, we've saved the most difficult part for last. So I can see the height of this pretty easily. Anybody know what that height is? It's 4. It matches this, right? So this is 4. Now, this base right here is a little bit more difficult to see. So I think of this as like a garage door. If I took this and I pushed it all the way up, it would make that line right there. Would you agree? So this whole line has to match this whole line, right? So this whole thing from here to here including this part right here, has to be 11.4. Well, we see part of it is 8.4. Spencer, what is it? It's what? Are you thinking? 3. It is 3. Does anyone know how Spencer figured out it was 3, Alexis? Yes, this 11.4 minus 8.4 gives us 3. Or we could say this 3 plus 8.4 equals 11.4. Does everyone see that? To me, that was the hardest part students had in 6th grade, was finding the things that look like they were missing dimensions. Sometimes you have difficulty seeing that. So we are going to do the formula now, and that is 1/2 of 3 times 4. 1/2 of 3 times 4. So you could say 3 times 4 is 12, and then what's half of 12? 6. If you could figure it out like that, you would know that one is 6. Or on our calculators, we can put it in just like that. Have we looked at how to put fractions in on the calculator? So we will do that soon. So 1/2, that's our fraction for 1/2, times 3 times 4. And we get 6. And then what do? Add them up. 45 and 6/10 plus 33 and 6/10 plus 6. Where do I put the 6? Under the 3, right here. This 3. It's really 6.0, right? And then we're just going to add. So I have the 3 plus 33.6 plus 45.6. And we get 85 and 2/10 meters squared. And that is our answer. You should have all the math on your paper that I have on my paper. Questions? No? Okay, if you're done, you can put that up. If you don't have your math journal, you can get your math journal for working on the review. And you need to get the review done and then turn it in over on the table next to where you pick the papers up.